Hello, hello.
Hey.
I like just acting like I'm muted sometimes just to see, if I can throw people off.
It didn't work. I was not thrown off, Brent.
You saw it coming. Yeah, I get that. I respect that.
I know you too well, I guess.
Nice.
Yeah, this was amusing. Alex Smasher certainly
Someone
looked
saw
at
the
the tweet. So
Yeah, that was a great tweet, by the way. I loved it. It's so many things happening in that tweet. Follow up. So yeah, and of course, Mini Jerome. Welcome back, Mini Jerome. Here we go. So,
it's an important point to mention that when we tweet about the show, we always strive to have the greatest GIF possible when we tweet.
yeah,
and
it's
GIF.
a competition. Oh no, the peanut butter's in the in the counter, so I don't know. You meant GIF, right? Yeah.
Yeah,
okay.
We're just a bunch of gentlemen, standing around, sitting around.
Yeah.
We could do this all day.
I think that we have incentives to do this, right? So like every time we have a better GIF, then we get some incentives. So
it's true, but the process leading up to it, I've spent not just like a minute, but like 10 minutes trying to find just the right one. And it is hard because, Pavan or Brent, someone will put up a tweet the day before that has an amazing one. And I'm like, oh, how can I top this? Sometimes you just can't, and you have to accept that.
Have you ever found yourself in the situation where you have two perfect ones and you can't decide?
That's a tough one. Yeah,
that's tough.
Absolutely.
Yeah. I mean, I don't know. So, okay, we're following up. The show is a follow-up. What are we talking about? What are we following up on?
Well, we have our great guest we had last week, Gadi from Alcide. We we had a great session last week, and with the response and the things that we covered last week, we have Gadi on the show again. So welcome, Gadi. I'll let you run through what we are going to cover and probably give an insight into a quick recap of what we covered last week, which was great, by the way, which was great around security. So
absolutely. So we're going to do the same kind of fire drill, some slides, theory, and then try to do some practice. So let's do that. So for those who see me for the first time, my name is Gadi Naor. I'm the CTO and one of the founders of Alcide, and Alcide is purely focused on end-to-end security for Kubernetes, and Pavan kindly kind of is doing some propaganda work for us. So that's very nice. So I'll share my screen. So
and by the way, Gadi, you're an avid skateboarder.
I am, and there's a very hidden link, kind of a mysterious link between Kubernetes and skateboarding. They're both abbreviated with the same letters, K8s, and if you reverse it, that's skate. So.
Right.
I like it.
How about that?
Oh,
it all comes together. Yeah. And I just saw on your on Twitter that you actually have like a skateboard company too. That's really cool. So not only are you great in the security space, but you love the skateboards and you're following your passion, it seems, which is awesome.
It is kind of so trying to keep it cool in the clouds and cool in the streets.
Yeah.
Nice. Very cool.
Anyway, sorry, I just wanted to mention that.
Yeah, I was really impressed when Gadi shared a video of him skateboarding on LinkedIn, which was amazing. Like just having fun, and it's great to have a co-founder who's found a company based on Kubernetes security, and has an online presence on the skateboarding side as well.
Yeah. I have to say, like, our office is like right across the street from a skate park. And I've taken.
It's not an accident, is it?
It's not. It's not. But we had like few occasions where instead of like doing lunch, I took some of the guys here, and we have like a bunch of skateboards here that I got in, and we all went to the skate park, and it was good. I mean, let's say that we didn't do any coding there. It was about anything but coding. So good stuff there.
Super cool.
And we are hiring, so for what it's worth.
Nice. Remote friendly, I assume.
Yeah. I mean, we can do remote. I mean, who's not doing that?
With your resume, you have to send a skate video of your, all the tricks you can do, kick flips, what are they? Ollie, I don't know, Ollie pops. I don't even know the skateboarding terms anymore.
Backside, front side, and all that. Yeah.
There
I mean, we can do a talk on that if you want.
I play Tony Hawk's Pro Skater, so I feel like I should know more than I'm saying.
That makes you almost a pro yourself.
Exactly, right? That's why I could relate. Even though, no, I can't skate.
All right, so I am sharing my screen. Let's see. All right, so, and I will resize, and I'm going to keep it like really short. Sure. So we talked about, in the previous session, we mainly focused on this area, like the pre-flight supply chain, the challenges that we have with configuration files, image vulnerability scanning. And once we kind of finished with the pre-flight checks and all that, there's always the challenge of, what's going on with the runtime. And when we think about the runtime, we can really break it down. And I'm sorry, like for the architecture slides, that's kind of the best I had.
No, that's fine.
But when we really think about runtime, we can pretty much break it into three elements. The first one is pretty much enforcement on configuration. That's admission controller in Kubernetes, and we covered that in the previous session. Luckily, everything is on YouTube and on the mini site for containers from the couch, so that's there. Once you move from that into the runtime, like processes actually going live and doing API calls and all that, so we really have challenges around process level security, making sure that processes are behaving with an expected behavior. And the definition of an expected behavior is something that it's not straightforward to establish. The second element relates pretty much to the network security side of things. And there's a theological kind of debate whether, host level and process level security versus network security are the preferred ways of implementing security. And the third element really revolves around monitoring your Kubernetes infrastructure. I mean, you have the API server, you have users, you have automated services that can, deploy stuff in the cluster, operators, all those cool things we have in Kubernetes. And we really need to make sure that neither of those components were breached and were actually are serving as a building block for mounting a wider attack on your cluster. And the other thing that we kind of talked about, and we can definitely talk about use cases.
Gadi, sorry to interrupt, but whilst I like that slide. I mean, that slide, the one that we covered recently around the runtime, it's absolutely fantastic because one of the feedbacks I received when I was giving like talks around security was this distinction between the pre-flight checks and the runtime security piece. And can we spend some time defining what runtime is? Because we have kind of viewers from different segments, and I just want to explain really what runtime means and where does it fall in terms of the whole life cycle of building a container and then deploying it in an application and running it.
Absolutely. So if you really think about configuration as the pre-flight, the runtime can really be captured as the in-flight. Everything that happens while the airplane, your application code, the processes that you actually built are running in flight, simple as that. And the in-flight for Kubernetes means a couple of things. The first one, if you are a cluster operator, the in-flight of your infrastructure necessarily means that you need to make sure that your control plane is covered, luckily, if you're running on EKS, it removes a lot of burden from a security standpoint to make sure that all of the moving parts of your control plane are intact. But the nodes are as important when it comes to kind of the vehicle to run your pods and containers and all that. Applicative workloads. Yeah, sorry, go ahead.
Yeah, I was just saying, I love the analogy of flight, and since we mentioned plane as well, like, yeah, it's about making sure we have the pre-flight checks in terms of security done through the CI/CD pipeline, and whilst we are building the containers and the whole application, but when we are actually ready to fly and ready to deploy the application once it is running, that's the kind of the in-flight position where you have things running. So how can you secure those running things, right?
Exactly. And when we really think about, risks that you have during a flight, so take that analogy and think about what type of risks can happen when your application components are running. So for example, someone can breach it. So someone can breach the airplane, something hits the airplane, or, someone can breach it from the inside. So think about that. It's a container image that already comes with a vulnerability or malware that was injected to the container in your registry even before the airplane was airborne. And then once it's in flight, this threat becomes kind of reality. So that's kind of an analogy of how we can think about internal born threats versus, externally introduced threats into your application. And that's mainly falls into the category of traditional application security, where someone tries to hack into your application. So that's pretty much kind of the breakdown.
Brilliant. Yeah, love that.
And when you really think about how can you monitor, or the detection side of things, and how can you prevent, so the detection can track signals from either how the process is working, meaning, how do they access system calls? How do they access files if you're running, traditional infrastructure? And how do they access the network? And prevention is definitely something that revolves around what measures you have in place to prevent those threats. And prevention can be defined in a couple of ways. First one is preventing from exploits from even happening. And then what happens, or kind of a post-breach prevention, like preventing from exfiltrating data from your environment. So for example, network policies like security groups, for example, it's a great vehicle to prevent exfiltration of data. So even if someone managed to get into your container, they cannot extract anything out of it because it's pretty much caged.
Makes sense.
All right. So when we really think about that, the threat landscape and also, or maybe kind of the use cases that we can see here, pretty much boils down to a sample of use cases that are relevant when it comes to the different runtime components that we want to monitor. So for example, when we talk about the in-flight of processes, we can think about network segmentation. So those Kubernetes network policies can take you, for example, from segmenting workloads like pods, talking with pods from another namespace. If we think about more advanced techniques, Kubernetes has DNS open by default. And the oldest trick in the book in terms of what malware can do inside your cluster is actually leveraging inherent weaknesses within the DNS protocol to use it as a covert channel and exchange data, because I can do DNS queries all day. So if you don't have explicit mechanisms that tries to detect that, malware can easily exploit those vectors within your environment. And I'm not saying that it's easy to get there. And you should always think about security implementation as an incremental effort rather than, a one-time, hammer in the nail and that's it. It's a work in progress always.
Absolutely.
It's a great point.
And just to give you a headache, here's some of the risks that you can benefit when it comes to Kubernetes. It may seem that it's a lot, but if you really think about it, the fact that you have Kubernetes as your application vehicle or infrastructure, it gives you a really well-known grounds to kind of prepare for the battle in a lot of ways, because this is a war, like how you can get 1 step, 2 steps ahead of your perpetrator or whatever, and this framework actually helps to put this in context. So I think that with that in mind, let's try. Yeah, go ahead.
Sorry, Gadi. I was just saying, I've just pasted a link to the MITRE sort of threat metrics and the one that you've shared. It's a great resource for organizations that want to do threat modeling and want to assess what kind of risks they need to address and what kind of tools would help them address those. So this is a great slide. I love this slide because it picks up a CVE, and we have noticed since 2018, we on our security bulletin, we've noticed more and more security bulletins around containers and Kubernetes, and we do the great bit around securing the control plane and making sure the environment's up to date from a managed Kubernetes perspective, so that customers just worry about running, or their responsibilities around running the actual application. But building upon something solid like the MITRE attack framework is a great resource. So thanks for bringing that into the mix, Gadi. This is very useful.
Absolutely. And here's a nice anecdote from our previous show. Until today, there are 4 new CVEs disclosed on Kubernetes. So that tells you kind of how active this area became, because once you have infrastructure that serves a lot of interest for, the black hats, the red hats, the white hats, and all that, they will start surface, things once they start to dig deeper, and that's some sort of a manifestation of those efforts.
That's
so 4 CVEs, yeah.
Absolutely, and just so that the viewers are aware, CNCF, which is the kind of parent organization, nonprofit, which manages these projects, they have an interesting security review mechanisms where they would bring in external assessors like penetration testers and assessors to assess these programs. Like Kubernetes has gone through an assessment as well, and it's available. The security assessments available on the GitHub repository, and so have some of the other projects. But regardless, having gone through an external assessment like you do as an organization to assess the software you're using in terms of security weaknesses, these are new vulnerabilities which are being published every week, as you say, Gadi. So that's really something to bear in mind when customers are running and owning responsibilities around security.
Yeah, absolutely, and actually, I'm sitting at SIG Security on a regular basis, and that's definitely part of the things that we are doing there. So yeah,
right.
That's
sorry
definitely
to
part
interrupt. Yeah. Good. Yeah. Sorry. Go ahead.
Good stuff. Yeah. So I think that on the MITRE link that you sent, this is great, and the one thing that they're not covering is infrastructure specific threats. I mean, MITRE historically was more geared toward IT challenges and kind of corporate network challenges, and the body of work that Microsoft put with the version 1 of this matrix and the work that we had done to kind of take it to the next level as far as the Kubernetes threats, it gives a good framework how to think about and go about your security implementation, and the fact that the managed Kubernetes side, like EKS control plane, is like covered by your cloud provider. That's amazing things, and it removes a lot of burden from a security standpoint.
Awesome. So you're moving on to something
stuff
to show, right?
Yeah. Let's see some stuff. So what I wanted to show is mainly around the three areas, and we'll see how much we'll be able to kind of get. So it will be partially command line and some kind of dashboard that will show us better things. So I would like to start with it's a product capability that we built into, and there's a code lab that actually you can run through that. And the basic mechanism around it, when you think about containers, you sign the containers to attest whether this is something that is coming from a trusted source. But when you really think about it, what really interests us is what is actually running inside the process, inside a container, like the actual processes. So one of the mechanisms that we built into our runtime security is the ability to, as part of the build process, to tell in container build time which binaries are expected to run. And this is something that you would expect the average developer to understand and be able to say beforehand. And once we are able to tell that, we can actually attach a checksum, like a binary checksum, a SHA-256, something that is cryptographically secured, and add it to the container build. So it is signed as part of the build. And once containers are being provisioned into the environment, we can verify the actual process binary checksum with the policy manifest that we embedded inside the container. And any deviation from this whitelist means that something is off. Or for example, if the policy manifest is absent from the container, so this is something that means that we are not covering this container. For example, it's a third-party container. So that's kind of the basic motion that we have with this capability. And the process is quite simple. So basically the way to do that is we created, and let's see kind of the Docker file that does that.
So would this be file integrity monitoring?
No, this is, so in a way, this is kind of a reactive file monitoring in the sense that we will detect which process is running, look at the file checksum, and verify that this is indeed the file that's running. So we're not looking at process names or anything of that sort.
Got it.
And the way that this mechanism works is that we specify in the container, in the Docker file, we generate this manifest in a way that tells us which application will run inside of it. And as you can see here, this container actually is running another binary. And essentially in runtime, we will be able to detect that this is something that actually violates that. So I already ran that beforehand and kind of in order to save us the time of building the container image and pushing that to Docker Hub and deploying. But so let's take a look on how this would look like in a runtime environment. So what we basically see here, I'm switching over to the dashboard screen here, and we do have something as part of the detection here that basically specify violations of the process whitelist. So let's take a look how this violation looks like. So we can really see here, let me see if I can.
Much better.
Yeah.
Yeah. So what it really means here, and again, let me see that I can see what, all right. So what we can really see here is on my EKS cluster, basically an attempt that this pod was running a process that violated this policy. So I had essentially something that was running inside my container. And again, this is a container level kind of verification. And inside that container, we were able to detect that the expected checksum of this process is not in accordance to what's signed inside the file. So it really means that someone practically modified the binary. And there are many reasons why this can happen. I mean, network breach and all that. So this is actually takes me to the second point. I mean, you cannot have just one type of defense. You probably need and want to have more than that. So let's try to think for a moment, like what would we need in order to modify a binary inside a container? I would need the file system to be writable. And again, going back to the pre-flight checks, if we were able to configure our pod to have a read-only file system, this is something that could have prevented this type of, modification of my container environment. If I were to segment the pod and prevent someone from doing, like wget and downloading a payload, that would be something that would prevent that. If I were to be able to build my container from scratch and have no shell environment, I would probably be able to do something like that. So it gives us a nice extension to container image signing by signing like the expected behavior of the processes inside a container. So it's kind of a different approach to container monitoring and Kubernetes in general.
If you kube control exec into a container where this is being monitored, does it set off alarms? And maybe it should.
Yeah. I mean, that's exactly the thing. I mean, once you do the exec command and start, poking inside a container, then this is exactly what would happen when it comes to that. So that's one area that we have with this. And again, when you think about runtime security, there's process level security, this type of behavior, versus the network security. So let's talk a little bit about the network security side of things and see some examples of how things behave once you go into that. So what I would like to switch is go back again to the alerts screen, and let's talk about crypto mining and all that. So I can see someone picked a question about what about those ephemeral containers and those debug sidecars. So they will not set an alarm. And the reason for that, because this is a container level check where you monitor the containers, if you don't have the embedded policy inside a container, it will set only one alarm, that you're missing a policy manifest that tells which containers are supposed to run, which processes are supposed to run inside this debug container. So it will happen only when you debug your cluster, and it's okay to signal your security team that, there's a debug session right now inside my cluster. That's okay. I mean, this is a reasonable balance of trade, I would call it, between security needs and kind of, reality and engineering needs. So thanks for the thumbs up on the view. I'll show you some more sexy stuff. So when we really think about reputation hits, so think about crypto mining. One of the things that we are worried about is someone abusing our compute resources to do some mining. So what normally happens with crypto mining is that we have software running inside our container, connecting to a Bitcoin pool or something that can tell us what's going on inside the network. And if we are able to detect based on threat intelligence feed, so you can really think about it as like guard duty, like pod level guard duty plugged into your EKS cluster. So what it really gives us here, and again, let's see an example of that. We can see here an asset, and I'll drill down. So this is an example of a crypto mining. Let's search through that. So this is an example of a pod that performs crypto mining. So we can see that the system, the runtime monitoring, actually picked that the system is trying to connect to mining.bitcoin.com. So if you go to those addresses, you will see some websites there that offer you to kind of mine, kind of commit your compute resources to do some Bitcoin mining. And the nice thing about it is that you can pick it from DNS queries inside your environment. Now, for the quick ones in the audience, you will be able to see that we also saw those events on the DNS infrastructure. So if you think about it, pod performs a DNS query. It goes to your DNS server, like the in-cluster DNS server. This cluster will forward a request to the outside world. So effectively, what we see is how DNS queries are traversing the cluster. But the origin is pretty much the pod that we saw here. So let's take another look on this pod and where exactly it's running. So basically, this pod right now, so what I basically did is I managed to pivot from the alert to the actual asset on my EKS cluster. So what I can immediately do is pretty much see on which host, like Kubernetes worker node, this pod is running on. I can double click on the node, and it's not Bottle Rocket today. This is plain good old Amazon Linux 2. I can also see immediately like which are my neighboring workloads. So from an investigation standpoint, this is something that really serves value to understand blast radius and things like that. Right now, we're talking about, Bitcoin mining. It's not a malicious activity, it's just something that abuses resources. But you can really understand, and you don't need to be an expert to figure out, what's going on to your left and right. And that's the main purpose of getting a handle on that.
How would you? I know we all have questions.
Yeah. Go ahead. Go ahead, Brian.
I was just going to say, how would you react in this particular situation? Would you, since it's not necessarily, a hack or a virus or something, would you want to migrate all of your other workloads to, elsewhere in the cluster and then maybe isolate this node? Or like, what would you do in this particular situation?
So it's a great question, because it really depends on what kind of threat you're dealing with. And so let's explore a couple of options of response. The first one is, looking at some of the metadata you have on the pod and trying to figure out which is the engineering team that is responsible, and tell them, guys, you're running crypto mining inside your pod. What the hell did you do? Other option, if it's not something that came from engineering, you might want to kind of lock down the container. Now, locking down a container or locking down a pod oftentimes will result in a situation where Kubernetes will spin up another pod, pretty much because that one became not responsive or anything of this sort. So that's kind of the challenges when it comes to response in like highly automated systems like that. The third option is maybe isolating this by evacuating your node and making sure that, and by playing with, taints and tolerations, you can actually shift or make Kubernetes move all the pods to a single node. It's not necessarily easy to do it kind of while the entire cluster is flying, but that's definitely one way of isolating a threat. And then once you isolate it, you can plug a security group that maybe blocks the entire node except the Kubernetes kind of channels, or you can block individual pods, and that's the way to do. Specifically inside our platform, the way that we position it is you can plug a response workflow where you can deploy an isolation policy on the pod and then try to take it from there. But if you want to do like forensics analysis, you need to log into the pod, to the node, and take a snapshot of the containers and take them offline, and performs, kind of analysis of the file system. So there are many ways of going about it, and it really depends on the type of the threat that you see there. But security is not easy. It's a profession.
Yeah, and what I love about this interface, Gadi, is the way it helps triage the incident. So when it comes to phases of responding to an incident, you'd like to first find out where the incident is happening. So this view is highly useful if you're running a few clusters and you want to manage them, and it provides a really good response mechanism in terms of if you're an organization like or a business unit which requires or responsible for incident response, then you need something like this. I think we had another tool from WeWorks when we had GitOps demo done with them on the show. They had a tool which I forgot the name of, but yeah, I mean, those are the couple of tools which I've come across where you can actually visualize your clusters and go deep into where things are running.
Yeah, and this is a great point. I mean, right here, what we see in front of us is actually a runtime view of the network activity in the past 24 hours of this specific pod. And it visualizes really nice, even all the way up to the domain level. The activity, I can literally like drill down and see like actual network traffic and stuff like that. This is the type of stuff that only runtime monitoring can give you on pods and containers for this matter.
And I do have a question, but Brent, do we want to let's address techie stories first, and then I want to ask something.
Okay, sounds good.
All right, so we have a question whether this is a SIEM type of investigation product. No, so the way that we pretty much think about it is we are oftentimes will be a secondary investigation dashboard, and normally what would happen is we will integrate with your Security Hub or Splunk or whatever you're using as part of your stack. And on certain alerts, you'll have backlinks that will take you into the right context inside the right cluster for a deeper forensics analysis. And oftentimes, forensics investigation involves multiple tools. It's not just one dashboard or one tool in practice.
Yeah, and actually, so Techie Stories does ask, is it API integration? And this kind of leads into my question is, so I'm generally not a huge fan of humans having to go and respond to things. Obviously, for forensics after the fact, I think that's okay. But what about automation from this point? So we've detected that we're mining Bitcoin. Is there any way within Alcide that I can then trigger a Lambda function to maybe do something, or a notification to a security team?
Absolutely. I mean, the way that things are working is you can pretty much fire an automation workflow that via API push policy that segment this. It definitely, as far as integrations, I mean, we can fire hose those alerts to external systems, and then those systems would trigger playbooks that would do the response workflow. And that's pretty much how things are implemented in real life. At the SOC level, at the incident response kind of team level, they would have the playbooks for certain events, and based on that, they will kind of connect and wire the API calls that needs to be. I mean, the dashboards are nice once you need to have a context, a wider context when you investigate, and you need to kind of step aside from the command line and the logs, or go back there. It's pretty much boils down to that.
Nice.
So Techie Story says, so you have it, and this kind of gets a little bit towards my question as well. So you have a data harvesting and data observatory platform, and then you create investigations based on the data. She wants to know, is this based on or centered around Kafka? And I mean, that kind of, go ahead, sorry.
Yeah, no, I mean, I'm saying Techie Stories, she definitely knows our game. I mean, we have Kafka in our systems. That's pretty much our data backbone for everything. So yeah, definitely.
So what I was wondering is, earlier you were talking about anomaly detection, and we kind of dove into this example, but let's just refresh, a little bit. This is an example of anomalous behavior, right? This is just, hey, your container's been up and running, and especially, I'm sure you're tracking the history of, that container deployment, throughout its versions and things like that. And then all of a sudden, we start to see this anomalous behavior. So that's something that it doesn't I guess where I'm going is, this seems easy to spot because we're connecting to wallet.bitcoin.com. But in reality, it's probably just as easy to spot simply because we're doing something new that the container doesn't normally do. Is that fair to say?
It is fair to say, but the reality is that learning, and here we're talking like AI, learning what's kind of the expected behavior of something, especially in dynamic systems, it's not straightforward and it's not trivial. And and traditional machine learning algorithms would fail miserably in environments like Kubernetes. I mean, our AI internally is not based on supervised or unsupervised learning. We are actually doing statistical based behavioral anomaly detection, which means that we are learning the behavior of the microservice and the cluster and the detections and the anomalies. And we have two types of events. We have anomalies. So before the system will fire an incident, it will fire anomalies. And anomalies can be tracked and identified in exactly the same way you mentioned, because those are automated systems. So they have their behavior has a very strong patterns. I mean, if they interact with microservice B or service like AWS service, like RDS, they keep doing that. I mean, databases are extremely simple creatures. Nobody fires an egress connection from a database. Everyone connects to a database. So it's really easy to kind of establish those baselines, assuming you have the signals, like the evidence to actually build those profiles. So here's an example here of a port scan. And port scanning is an example where thresholds are a strategy that is doomed, because an attacker can pretty much do a low and slow scan, and it will live below threshold, or you can have something that is spiky. So this is an example that kind of detects port scan dynamically inside your cluster, and you need to learn what this thing look like. I will say that, and we actually had a blog about it, we did a comparative kind of test of spoofing attacks on all three cloud providers. And I'll be honest here, like this is from day one. Our security tests on EKS always fail because we cannot run the exploits and the attacks that we are trying to run, like the lower level attacks. So EKS has like VPC networking, has very like excellent security hardening out of the box, which I cannot say on other areas of other Kubernetes clusters that we had seen. And we do have a blog about it, a recent blog about it on our website. And if you recall, again, going back to CVEs, two recent CVEs were around spoofing attacks, and both involved like layer 2 type of spoofing attacks. So it's kind of a nice thing to see where you get out of the box secured experience versus you need to work harder for that.
Very
so
cool.
That's on the net. So we covered process level security, and we covered network security a little bit. And I mean, there is, on the network security side of things, there is a universe of other, types of exploits and covert channels and all that. So we're not going to cover that here, but I do want to show you a little bit of color of what you can get from the Kubernetes audit log. So going back quickly to a slide to give you the lay of the land of how this thing looks like on EKS. So pretty much everyone should do that. It should be a no-brainer. Your EKS can ship your Kubernetes audit log. So these are the logs that Kubernetes emits on every API operation that is being performed in the cluster. If you kubectl exec, there's a line in that log. If someone create a pod, there's a line. If someone has an action that is being denied, it's captured inside the log. Basically, EKS will ship that to CloudWatch, and using things like Kinesis, you can basically stream those logs to external analysis system, which is exactly what K8s, which is our Kubernetes audit log analyzer, is doing. And then based on that, you can pretty much ship detections to third parties. And for example, we have integration with Snowflake that actually captures exactly that. When you use Snowflake as your pretty much cloud native SIEM for threat detection and doing that. So you can do two main things to do with your environment. The first one is establishing policies. If I'm executing into a pod, I can pretty much fire alert to Lambda that would perform actions based on the user identity that performed this exec. You can, for example, block the account. The other notion is pretty much AI-driven. I want to learn to establish a baseline of what type of resources are being accessed, what type of operations are being done, and then based on that, I can detect deviations from this baseline. So let's take a look around that. So, and I didn't pick the question there that was.
So I think I answered it correctly, but Techie Stories says, so this requires centralized log management or product-based log. And just to confirm, you're talking about the logs from the control plane, right? Correct. So we'd be able to, all you have to do in the case of EKS is check a box to turn those on if you haven't already. And then you have centralized logging from the control plane into CloudWatch. And then from there, you can, as Gadi points out, you can ship that to whatever you feel like shipping it to out of CloudWatch.
Exactly.
And then she follows up. The reason she asks is, asking about the latency in threat detection. What is the latency of the operation? I'm guessing it would just still be seconds.
It's a matter of I would say near real time, and seconds would be, or even the magnitude of 20 seconds. That's pretty good when it comes to detecting threats based on log analysis. So it's not inline, and it doesn't affect your cluster performance whatsoever. So oftentimes, you will hear pushback from folks that say, runtime security agents introduce overhead to memory, network, CPU, and all that. This type of security monitoring is mainly by analyzing logs as a side kind of, engagement or activity, and not in line of your application running inside your cluster. So what we basically see here, it's a timeline that pretty much captures detections, anomalies, and activities that are being performed by users. And I would like to show you, kind of walk you through an investigation that one would kind of take. So I'm zooming in on one of our users here, and I can basically see the world based on a way that I dissect or intersect the data flowing from the EKS log or from your Kubernetes audit log, and I can see some events that are happening inside this environment. So I can see all sorts of anomalies. So for example, one of the fingerprinting methods that we have for Web APIs is the user agent that is being, that's pretty much an HTTP header that we have on every API call. And on normal cluster and normal operation, those user agents would be something that can help us profile or identify the cluster. It's really easy to spoof or pretty much impersonate your API calls with those headers. But if the attacker doesn't know what are those, for example, characterizing aspects of your traffic, then this is something that can help us detect anomaly. We can see here that Nitzan was performing API calls with a user agent that is not something that the system had seen before. We fire an anomaly, and we can see that here over a timeline. One of the things that we can really do using that is actually try to see the user activity. So for example, and this is something that always kind of captures the audience, I can see execs. So here's a nice view that actually tells a story which assets were accessed and when. So if I'll try to visualize that.
This is really nice.
Yeah.
It's extremely hard to figure this out from just watching logs. And think about it like, you can see here examples like which users accessed which pods inside our environment. And that's, for junior kind of security analysts to kind of understand. And if you do security investigation, you normally try to look at things on a timeline kind of view to understand context, what happens before, what happened after. So this is the superpowers that you can actually gain from looking at your Kubernetes audit log when it comes to all of those activities. And again, let me show you another example. So this cluster actually is criminally internet facing. So we did that on purpose. And you can see that, and again, this is something that happens all the time. You would see generic internet scanners, but sometimes you will see Kubernetes-specific scanners that would try to make unauthenticated API calls to our environment. And you can see, I can promise you, we do not have engineering offices in Russia nor China or anything of that sort that you see here. And that's the type of information that you can get from audit logs.
This is really cool.
Yeah.
Is the cluster, are we looking at a single cluster and is
That's
EKS cluster?
Yeah, correct.
So in the case of EKS, then, like, because we publish control plane logs through a simple API or a setting on the console, this provides customers a great insight into what's happening within their cluster, and they can
exactly.
Because using the control plane logs is something that that we need to showcase, and this tool does that. So it's very, very cool. I'm super impressed.
Yeah. So Techie Stories, I think, I don't know if we warned you ahead of time, but she's our resident security expert. Well, Pavan's our resident security expert, but Techie Stories is our resident security expert in the audience. But she wants to know, hackers usually know the characteristics of the API. So is this using algorithms such as the Kalman filter for user behavioral analytics? And then...
All right, go ahead.
I'm just going to put them all out there, and then you can address them however you want. Are you investigating the cluster and container behavior as well as user behavior? And then, she says, I have some tough questions, but I have to say I love the product.
All right, so thumbs up on the love the product, and you do have kind of very good questions. So let's start with, we are using statistical behavioral analysis of specifically on the audit log. That's only users. So that would be kind of human users or automated service accounts. Specifically, if you want to know, this is kind of patent pending. We are using belief networks. That's kind of the underlying AI algorithm. So it's not Kalman filters or anything of that sort. And it's a very specific and highly accurate kind of detection mechanism. So the CVEs that we had on Kubernetes, we were able to kind of pick those when we tried to run similar exploitations, pretty much because the algorithms has a very high success rate in detecting new stuff, things that didn't happen before. And in automated systems, when someone tries to kind of poke them, that's exactly the type of stuff that will surface signals. And on the container activity, our actually AI that is doing the network security analysis is leveraging similar algorithms, but the substance or the signals that we are using is different. Here we are using audit logs, and for the network stuff, we are using network activities and protocol kind of signals and bits and bytes from there. So I think I answered all the questions.
Yeah, for sure.
So I think that was a lot, and a lot of really good info. I think we probably should be wrapping up now, but I just want to say, like, so in our previous show, Gadi, we went over, and I love, as Pavan was saying, I love the flight references. So we talked about pre-flight, right? When you're on the runway and we start to get ready before we take off, right? So we're talking about all the things to secure takeoff. Now, but today what we did was we talked about the runtime or the in-flight, and I think we always talk about defense in depth and security, but it never ends. And the thing that really stuck out to me was that I'm calling it in my head binary integrity monitoring. I'm calling it BIM, patent pending, trademark pending. Just kidding. But because at the end of the day, I think we oftentimes talk about the external bad guys coming in, but we don't always talk about the internal bad guys, bad people, right? Trying to do bad things. And it's obviously rare, but we have to keep an eye on that. And so something like that is a great way to catch maybe an internal bad actor that jumped into a container trying to do something nefarious. So it's all about that defense in depth. I just want to say, really just wrap the bow on it today.
Nice. Yeah.
Absolutely.
This is incredible. And Pavan, or someone popped up the free trial link.
Yeah.
Can we pop that back on as we get out of here? Because I know people are going to want to try this out, and it looks so easy to do. And like you said, a lot of what you turn on and implement doesn't really even affect the performance of your cluster. So that's pretty awesome.
Yeah, absolutely. And just to recap on some of the tools, open source tools that we covered last week on the show, there was Scan, there's Advisor, which is a great tool, which was super impressed, where you can take a signature of a cluster, of a good gold standard cluster, and use that for creating another cluster with those security settings. And there's, what else did I miss, Gadi? I mean, would you like to cover the open source tools as well, if you want?
Yeah, and for those of you that want to try like something that I dropped earlier today, EKS, ECR, vulnerability scanning in seconds. Go ahead and poke it. It's not announced yet, so this is kind of world premiere here. And hopefully we'll do kind of round 3 on the couch and kind of dig deeper on that.
You're on. Absolutely.
It's a deal.
Very cool.
Great.
All right. Yeah. Well, so we look forward to that, and we should dig into it and see what it's all about ourselves too. But thank you, Gadi, for joining again. And this has been great. Everyone go take a look at it, and send us feedback. Let us know what you think. And until next time.
Great. Thanks, Gadi. Thanks very much. Thanks, everyone.
Thank you for having me.
Thanks, everyone, for joining.
You bet. See ya.